Welcome to the LemnaTec Academy. In this video, I will talk about a more technical yet important aspect of the software: the different types of data we deal with, when they are created, and what purpose they have. In the LemnaTec system, a lot of different data is created while you are using it. We have the experiment and its metadata. This includes the description and the definition of the annotation columns. Most importantly, we have the recorded images with their metadata. Then we have the analysis results, which are created using some analysis definition. And finally, we have sample annotations, which add external information on samples to the mix. The results and annotations can then be evaluated in the result viewer of LemnaExperiment. But in which order are these data created? Some cases are obvious. For example, no analysis result without recorded images. But other cases are less obvious. Do I need an experiment definition before I can record images? Or when are sample annotations added? There's no simple answer to this question, as we support a couple of different options. Let's start with the probably most common case. Images are created on the device and are assigned there to an experiment and vessel. This is transferred to the database. This creates automatically an experiment definition if it not yet exists. However, the experiment metadata is effectively empty. But you can add and edit these later in the process. In the other two options, you would create an experiment in LemnaExperiment before any image for this experiment has been recorded. Or you import an experiment definition from an Excel file before any image for it has been recorded. Now we have experiment definitions and image data in our database. The next step is to execute the image analysis, which will give us analysis results. First, we need an analysis definition and apply this to selected snapshots from the recorded data. These analysis tasks are called analysis jobs and are executed via the analysis executor. But what about the sample annotations? They need to align with the analysis results. Therefore, we need to know which vessel configuration was used. And because of this, the annotations are created together with the analysis jobs, unless they have been created earlier. At this point, we can use the information in the analysis definition to fill the annotations correctly. But what values are filled into these annotations? First, it is important to understand that annotations here are per sample and per snapshot, so they can change over time if needed. And second, annotations might be empty, aka no annotation data column are defined in the experiment definition. Nevertheless, these empty annotations are required for technical reasons. Then again, which values are filled into these annotations? If an analysis job is created, we first check if the samples of the snapshots have already been annotated. If yes, we are fine, no further action needed. If not, we check if we have earlier snapshots of the same vessel that has been annotated. If we found such snapshots, we use the values from the latest of them. Therefore, if you have annotations that does not change over time, then you need to annotate only the first snapshot of each vessel. If we have no prior annotations, we use the default values defined in the experiment definition. I just said we add annotations automatically only if the snapshot has not been annotated before. This could be a previous analysis that has annotated this snapshot, or you, the user, have added them. There are 4 ways to do this. You enter sample annotations manually in LemnaExperiment before or after you have recorded images. More on this in class 5. You imported sample annotations from Excel files prior to starting the experiment. Again, more on this in class 5. You imported sample annotations from Excel files after you have recorded the images. let's have a look on this from a different angle. Here we see the 4 major data types on some kind of timeline. And we have essentially 5 times where we can send data to the database. 3 of which are optional, which are displayed in gray. First, we may import experiment definitions and/or sample annotations from Excel files, or we may enter them directly into LemnaExperiment. Second, we record images with Lambda control. At this point, experiment definitions will be added if it has not been done before. Third, you may import sample annotations and/or update experiment definitions from Excel files. Or you may use LemnaExperiment to edit experiment definitions and/or add annotations. Step 4. By creating analysis jobs and executing them, we create analysis results and insert annotations if they are not yet present. And 5. You may update sample annotations and/or experiment definitions from Excel files, or you may use LemnaExperiment to edit experiment definitions and/or sample annotations. This design has one important consequence. Once a snapshot has been annotated, its sample layout is fixed. If you later try to start an analysis for a different layout, the system won't let you do this. Assume you have an image of a plant tray with 3x5 plants, and you have analyzed them accordingly. Then the system won't let you execute an analysis definition for 4x4 plants, or just a single plant, because the snapshot has already been annotated for 3x5 plants. If you want to submit such a combination of snapshot and analysis definition, it will be marked as inconsistency. This way, we enforce consistency in your result data. However, if you accidentally run an analysis for a single plant on an image of a tray with 3x5 plants, you have a problem. For the same reason, you cannot run now the correct analysis. The correct analysis. That said, this is not a problem that can't be solved. But this is not the topic of this video. We will talk about this in class 5. I hope you understand the data and their flow in the LemnaTec system now a bit better. The next video will be even more technical. We will talk about data maintenance and backup strategies. See you there.